right, I promise not to make the other demos as long as that last one. But I really like that last demo. I know it took us an hour to get through it. But for me, it sort of fleshes out, how do we leverage platform as a service, right? And notice that all of my data was outside of my web role. I could have easily spun up 2 other web roles or 5 other worker roles or whatever, and the application would have continued to work exactly the same way. Not a single thing would have changed if I had 100 web roles running or just 1, right? And so that's what I love about the platform as a service model. The other key thing that I kept saying about platform as a service, though, is that if those virtual machines get reset, what did I say about the VMs? They're stateless, right? So with some scenarios, though, you need state. Or, I talked about being able to run startup scripts inside your web roles and worker roles to do custom installs or custom deployments. Man, sometimes I can't script it. We had this guy write this DLL in VB6, and who knows where he lives now. And there's this batch file we have to run that requires me to go in and do regsvr32 myself, and I have to, for some reason, register then unregister it, and then click on a button, and then whatever. So I've tried scripting it, it doesn't work, right? So sometimes I just need to be able to configure these things, right? Or I need persistence. I need to have some state that gets maintained, and I need to know that if that VM reboots, when it comes back up, it's got the stuff I put on there before, right? And so in the industry, we tend to call this infrastructure as a service. This is really more, you just give me a virtualization environment and let me manage my VMs, right? I'll start out with a base image, but from that point on, it's up to me to maintain it, right? Or maybe I'll even build my own image on premise and upload it into the cloud or something like that. And so we have that offering now. There's our virtual machine features. We support Windows Server and Linux virtual machines. And there's a family of Linux OSs that we support. Gives you a way to sort of build sort of flexible workloads. In fact, you can mix in one cloud service web roles and worker roles as well as virtual machines. So let's say, the question during the break was, what if I want to have, SQL or something like that? I could use Azure SQL, and Azure SQL is great, but it is different than on-premise SQL. And you don't get control over the physical storage of your data. Well, what if I need more control over the SQL piece, but I still like the web role, worker role, stateless side, right? Well, you could go build an Azure VM and install SQL Server in it and manage it just like you would an on-premise SQL instance. But mix that in with your cloud service so that your web roles and worker roles have direct connectivity to it. It's really cool. And you can also make virtual private networks between your cloud services and your on-premise networks. So if I take some workload in my data center, and this is where you really start getting into what a lot of people refer to as the hybrid cloud, right? When you're running your stuff or storing your data up in Azure, that's the public cloud. When you're doing it all down on your own data centers, especially if you're using sort of self-service virtualization techniques or that kind of stuff, that's kind of the private cloud. And the middle is when you have some stuff local and some stuff public. And that's sort of the hybrid cloud. And so with a hybrid cloud model, you put VMs up in Azure that you've decided you want to get out of your own data center for whatever reason that may be. But you still need those VMs maybe to be joined to your Active Directory domain, or you need to be able to secure the traffic between you and those VMs or something like that. And so you can set up virtual private networks and make your VMs appear as though they're just a member of your local network. Obviously, there's some latency between your local network and the cloud, so the latency is going to go up there. But otherwise, they'll appear as if they're on your net. So that's pretty cool. The other neat thing about virtual machines is that if you're a Microsoft shop and you're running Hyper-V, the virtual machines that you use on premise are the same file formats and everything that you're going to use for your virtual hard drives up in the cloud as well, right? So I could basically have my data center where I've got my own VMs running, and if I wanted to migrate one of those up to the cloud or vice versa, I could basically take the VHDX or VHD from my virtual machines on premise, upload them as blobs into blob storage, and then configure a virtual machine to run off that VHD up inside Azure. Or vice versa. I could pull down a VHD for an Azure VM and run it on premise inside my Hyper-V installation there. So that's pretty cool. In addition, because they are just VHDs. Basically, any other service provider that supports that format, you can take that virtual machine and ship them off elsewhere as well, right? So you're not locked in here at all on premise, in the cloud, or whatever. You're free to take that file and move it off with you wherever you want to go. We also get that same awesome benefit of, remember, the triplicate redundancy of your storage, right? So when you go out and create a VM and you have a VHD and blob storage, there's triple replicates of that, right? So you basically have 3 copies of every virtual hard drive inside that data center. And should any one of those virtual hard drives fail, the Azure Fabric Controller is just automatically going to go build a new blob, get it all back up to sync, and you're good to go, right? And that happens transparently to you. You don't see that happening. So it's reliable, always on with your virtual machines with your persistent drives. All right, and along with that, geo-replicated. So not only is it replicated in triplicate on-premise, but also, as long as you haven't turned off geo-replication for the storage account that the VHDs are in, then they're also being geo-replicated off to your sister data center. All right, let me jump over here really quick, and I'll just show you quickly provisioning in Azure VM. But really, if you've played with VMs anywhere before, there's not a whole lot more to these than you'd be used to in most virtual machine environments. Let me just over here, actually go back to my desktop version. Jump over to my browser here. And sign in. I don't know why it's not signing me in there. All right. And over here under Azure, or under virtual machines, I can see that I actually already have a couple of virtual machines in place. But if I wanted to make a new virtual machine, I can come in here and just click on New. Under Compute, I have Virtual Machine, and you can either make one Quick Create or from Gallery. And I'll go ahead and pick from Gallery just so we can see that. And you'll notice that I get sort of this little wizard here, but it starts out showing me all of the images that are available. And those are broken down into images that are provided to you by Azure as part of the platform, or images that you've already created. And so in order to have an image, you would have gone in and prepared a virtual machine and then sysprepped it so that it's able to be redeployed and re-identified as it's brought back up. Or you could just have VHDs that aren't sysprepped, but that you know that's the virtual machine I want to build my machine off of, and pull it up that way. And then all just aggregates those all together for you in one big list. If I look through the platform images here, notice that we give you Windows images that have SQL Server, BizTalk. They're already pre-installed for you. There's Server 2008 base images, Server 2012, as well as various Linux versions down here that I mentioned as well. All right, so let's say I wanted a Server 2012 box or something like that. I can pick the one. Now notice that this is the last image that they've published out here is as of October 2012. Meaning that once you go in and deploy this guy, if there's new service packs or something that come out, they're not going to get magically put into this virtual machine. You're now responsible for service packing or hot fixing or anything else to this image. Once you create it, it's yours, and it's not going to get updated at all past that point, right? But so I could pick the image that I want, go on to next, and the virtual machine name that you pick is the computer name. In this case, the Windows computer name, right? So I'll just go call this the BS demo for Bret Stateham demo out there. And you're going to create the administrator username, and notice I can't change that, but I get to give it a password as well. And then a size of the virtual machine that I'd like to run on. Now, you can change that later on if you want to. It just means for now. So I'll let it use the small there. And go on to next. And now it's going to allow you to either be a standalone virtual machine or you can connect it to an existing one. You're actually going to get a cloud service wrapper around your VM, right? And so if it's standalone, it creates a new cloud service that's named after the DNS name that you specify here. So let's see if BS demo works. Okay, it does. If you instead choose to connect to an existing one, it'll join this into an existing cloud service and add it into there, okay? But I'm going to have it be standalone. And then it says, well, we're going to go in and create a VHD for you. Where do you want us to put that VHD? It's going to be a blob. It's going to go into blob storage. So you got to tell it which storage account you want it to use. And I have one here that I've created specifically for my Azure VM's virtual hard drives. So I'll put it into there. And then in which data center do you want this VM to run? I'm going to have it run in West US. Now notice it was bound to West US, and that's because I picked a storage account that was in the West US. So that's why it only let me pick that one region. So I'll go into next. And availability sets give you a way to basically create collections of VMs that can be run independently. You can do clustering and other stuff like that across from them. I'm not going to mess with that right now. I'm just going to go ahead and say OK. And now it's going to go out and basically grab that base image, that Windows Server 2012 base image, copy it over for me, bring it up, sysprep it, do all the stuff, name the machine, all that, create the cloud service, create the endpoints. And that takes a little bit of time, right? So this could take up to 10 minutes or so, or whatever, before that's complete. So rather than sitting and waiting, you see I've already got a couple other ones here. I've got this guy called Win8 Build, and I use it to help me build Windows 8 applications. But it really is just Server 2012, because we don't have client OS virtual machine images inside Azure. It's only server OSs here. But I've got Win8 Build here, and when I go to the dashboard page on this, there's some cool stuff that I can see. I've got some performance monitor type charts and things like that I can look at down here. As soon as it pops up, there you go. And down along the bottom, notice that I can control this guy. I can shut it down, restart it, whatever. Notice I can also attach new disks. So this goes back to that, that X drives, or the drives we were talking about just being VHDs up in the cloud. They're really just stored as blobs inside blob storage. And so I can come in here and either attach an existing blob, and when I do that, it's going to have me go out and find a disk that I've already created somewhere out in my storage accounts, or I can create a new one, attach a new empty drive, and it'll go somewhere in one of my accounts. Are you not going to ask me? There we go. Okay. Yeah, it's going to ask you where's the portal that it's going to go into. What do you want to call it? How big is it going to be? And then do you want to do any read-write or read-only caching on it or not? Right, and so you can configure that up. So I'm going to not do that right now. But anyhow, there it is. And then there's the other piece is Connect, and this is remote desktop. So I click on that, and it's going to go download an RDP file for me, and I can open that up and connect up to the VM. Now, when I created this VM, I created credentials on it, right? And so, in fact, I know that I have a specific account on this VM with my name and password on it. Oh, there it goes. Just took a while. All right, good. But there it is. I'm now logged in. So, and it's just a VM. It just happens to be running up in Azure's data center, right? And at this point, it's a Windows Server box. Go do to it what you would want to do, right? You can install stuff. Of course, the downside is I don't have, it's telling me I'm running out of disk space there, but I don't have a CD or DVD drive that I can drop a disk into. So installing, hopefully you have web-based installers, or you upload an ISO and mount it, using Windows Server's built-in ISO mounting capabilities or that kind of stuff. So the install process may be a little tedious if you're going to provision it all in the cloud. If you have complex setup requirements, you may prefer to build this image locally, just using Hyper-V. You go install Server 2012, you get it set up the way you want, you install anything you want to into it, and you install the Azure Virtual Machine additions for it, and do all this inside Hyper-V. Right? When you're done, you disconnect the VHD and upload it into blob storage. Right, and build it that way as well. So you've got some choices depending on how complex your configuration is going to be. But there you go. I've got it now. In fact, I've used this. In fact, you can see I've got this Microsoft Virtual Labs open. I've had a few times where my own local machine was having problems during a presentation. So I've just remoted into my VM to do my presentation from online. And it's actually worked fantastic for me. So anyhow, there it is. It's just a box, right? And notice that once I'm RDP'd in, it doesn't look any different than it would be if this were an on-premise network or on-premise VM there as well. So that's pretty cool. So those are Azure VMs. So, is there anything different about this RDP connection? For example, can I connect my local drives, etc.? So I've just turned that on in my remote desktop client there. And there they are. That's my local C drive. Yeah, and you can drag and drop and all that. So printers, whatever. Like I say, and I'm not demoing it here, but you can actually go in and configure virtual networks and even have this guy just be, a member of your domain, even if you want it to be. All right. So those are Azure virtual machines. Another type of service that we make available. So cloud services are kind of in the middle in terms of you actually had a fair amount of configurability with web roles and worker roles and all that good stuff. But you don't get control over the OS image. Virtual machines, you get a lot more control over the OS image, but a lot more responsibility. The other end of the extreme is no control over the OS and a lot less responsibility for maintaining the environment, and that's Azure Websites. With Azure Websites, we give you a very convenient way. If you say, look, I just want to make a website, come on, give me an easy way to do that, and that's where these guys fall in. We allow you to build ASP.NET, but we also have support built in for PHP, Node.js, etc. Lots of cool deployment mechanisms to get your stuff up there. And there's a free usage tier for these where you get actually 10 free websites with your Azure account. And that's perpetual. However, they're not running on reserved instances, and you also can't have custom domain names pointing into those. So they're going to be whatever your site name is, .azure-websites.net. But you can have them for free, and then you can scale up as demand requires. So with Azure Websites, let me jump over here really quick and go to my Azure Websites node. And again, you see I've already got some in place, but I can make one really easily. Just click on New, Website, and then there's a few choices that you have. I'll again go ahead and pick from Gallery here. And you notice that they give me websites that are pre-provisioned with Drupal or .NET Nuke, WordPress, blogging engines, Joomla, Orchard CMS, whatever out there. So a lot of ones that are just pre-set up and ready to go for you to use. Let me go back here. In fact, what the heck? I'll make a WordPress one. BS WordPress, BSWP. All right. Now WordPress needs a MySQL database on the back end. This is actually through a partner that we use. I'll show you that in a second, but I'll let it create a new one for me. Put the website in the West US region on that subscription. And for the MySQL database, it's from a partner called ClearDB. It's going to host the actual MySQL database for me. But I'll go ahead and call it the... that's fine. The name is fine. I'm going to delete this later. So, and just say OK. And it's now out provisioning that website for me. It's going to pre-install WordPress on it. It's ready to go. And it'll be a free site. Now, when it's done, I can then come into that site and scale it up if I want to. So right now, it's actually running on the free website mode. And notice that I can't really scale that up. But if I go to shared or up to reserved, I can then scale this guy up. With reserved, you can actually pick the instance size of the VM that it's going to create for you. And in a reserved instance, you can run as many other websites as you want. So that's pretty cool. Shared doesn't give you your own machine, but still allows you to scale up how many instances you want to be able to run. And that'll basically web farm out your website for you. And these guys can still use storage services and all that stuff, just like my cloud service did earlier that we were demoing. So that's pretty cool. Yeah, so we talked about the shared versus reserved. All right, I'll jump through that. And once you have reserved, again, you can run multiple sites across those. And I mentioned supported frameworks, ASP.NET, of course, any .NET code, PHP. Node.js is another real popular one. That's out there right now as well. And for publishing, how do you get your code up into the site? You can use good old standard FTP if you want to. You can use web deploy, which is built into Visual Studio. If you prefer to keep your code in Git or off in TFS, we actually support pushing directly from Git or from TFS builds up into Azure websites, and that's really cool. There's a number of other application building blocks. We talked about storage services, we saw virtual machines, all that good stuff. There's a whole bunch of other services that are available in Azure that you can use for your applications. So first of all, I mentioned the SDKs. So remember, as you go download the SDKs, we actually have support for a variety of different client languages or client platforms, .NET, Node.js, Java SDKs, PHP, Python, other ones out there as well. So you can download the SDK for the client layer that you need. I mentioned the open source. A lot of the SDKs are all published for you in Git, and you can go download those and use them. But we have, from the other services, another popular one is Azure SQL Database. And with Azure SQL Database, it is a cloud version of SQL. This is not the same SQL server that you're going to run on-premise, right? It has a lot of similarities. It has a lot of things that you don't get on-premise, and it has some things, or it doesn't have some things that you do get on-premise, right? But the core part of SQL, tables and rows and relationships and indexes and all that stuff, exists exactly the same way. And the basic stuff, you know, it's the 99% of the stuff you do is going to be the same across the platforms out there. So it's a regular SQL relational engine up there. It is on the Azure side clustered for you for high availability purposes. And in fact, it will still triple replicate your data up in the Azure data center. That's something hard to do on premise, right, is to get exact copies of your data on multiple drives out there. Fully managed SQL reporting is also supported as an additional service out there. And so to create one of these guys, this is different than creating a VM. Sorry, go ahead and leave that page. Remember I showed you that we had an OS image that included SQL Server on it, or as you saw me RDP into that other VM, I could have gone and installed SQL, right? It would be a regular SQL instance, and I could control it however it is that I wanted to. With Azure SQL, this is a different beast, right? First of all, Azure SQL is database-centric, not server-centric. On premise, you'll go install an Azure SQL, or sorry, a SQL Server instance, and then onto the instance, you create multiple databases, right? Here, we let you go make a database. And you go, oh, you don't have an instance? Oh, we'll make one for you, right? So we kind of focus on the database first, not the server first, right? The server is, in fact, really just a logical unit. There is not an actual SQL Server that's dedicated to you, right? You work with individual databases, and if you have a common security need across those databases, you want to have a common set of logins to access those, or a common set of firewall rules, then they can be logically associated into a server if you want to, right? But the server is, and for those on the recording, I'm doing air quotes, right? It's not a real server. It's this logical endpoint. So your server is really a name. It's a TDS endpoint that your client applications can hit, a collection of logins, and a collection of firewall rules, and that's about it, right? So it's really the database where your data lives, right? So I can come in here and create a new database if I want to. And this is going to be a SQL database, so I'll come in and do custom create, or I could also import this. And this would be if I had created a export using the DACFX framework. I could export a database on premise, upload it as a blob in storage, and then create a new database by importing this guy in from that. But I'm going to come in and do custom create so we have the most control. And I'll call this my BS demo DB. The first thing I get to choose is sizing. I have two editions, web or business. And right now, the only difference is the range of sizes that are available. With web edition, you can pick a 1 gig or a 5 gig max. With business, you can go from 10 up to 150 gigs max, right? Now, these are maximum sizes. So when you go to web edition 1 gig, you don't get 1 gig right off the bat. It starts as small as it can and fills up as you need it. The cool thing about that, though, is that you pay for what you use. So, in fact, the lowest usage tier is 100 megabytes, and that's $4.99 a month, I think. Then you go up to a gig. Anything over 1 100 megs up to a gig is $9.99 a month, and then you go up to the next one. And it's and it's you pay for each gig past that. You start paying additional, and the gigs get cheaper as they go, but the total still adds up, right, in aggregate. But anyhow, so all you're saying is don't let it get any bigger than 1 gig. And you can always come back in and just bump the number up, but this will keep it from growing past the size that you didn't intend and end up getting billed for that. You can also set your collation setting, although if you're a SQL guy, you know that you usually don't do that unless you have a specific reason to do so, either for managing performance or if you have international data sets that require it. What subscription and what SQL server do you want it to go on? And notice my server names are really ugly. You don't get to make up your server names. Azure makes them up for you. Right? They're random sequences of characters and numbers, and you can either use one that you have, or if you want to make a new one, pick to make a new one. I'll go ahead and make a new one here. And since I'm going to make a new one, I get to go to the next page. It says, all right, we're going to make a new server for you. What's the administrative login that you want to create? Think of this as like your SA login. So I'll just call it SQL admin, and I'll give it a password. Here it is. And I'm going to put this off in the West US. And this allow Windows Azure services to access this server. That's basically a firewall rule. It's saying we'll go ahead and open up the firewall for any code that's running in Azure to be able to hit this SQL Server instance. So I'll leave that on and say OK. Maybe. All right, so now it's out there creating my database for me. And that doesn't take too long. Let me dismiss my completed messages here. All right, so it's done. And so now I can click into that database, and on the dashboard page here, I can see some performance monitoring stuff about it. This button down here, Show Connection Strings, actually shows you sample connection strings that you would use from various client APIs to be able to connect to that database. That's really cool. I can close that up. I also have down here the server name that just got created for me is this name right here. Or I have a link to a Silverlight-based database management tool that I can actually use. So let me go click on that. This is going to go take me over to the management page for this database. Spins up the Silverlight app, and I can now log in with my credentials for the server. And log on. Wow, okay. So error connecting to the server, and that's okay. I'm going to come back to that in a second here. I could also attempt to connect to it from SQL Management Studio. So this is just a regular TDS endpoint, so you can connect to it from other SQL clients out there. But I need my server name. So let me click on the server here, and on the dashboard for that, I should be able to get the fully qualified name of my server. So it's this, whatever the random sequence was, .database.windows.net. So over here I'm going to paste that in and put in my SQL admin name and my password and try to connect. And notice I get an error over here as well. And it basically says you can't open it. The client IP address is not allowed to access the server. Firewall. It's firewall rules that are preventing me from getting into that. So remember when I made it, there was a checkbox that said allow other Azure code to get to it, but I didn't allow anybody else in. So back over here in my management portal, on the page for the server, so I'm in the server right now, I can go to configure, and it actually is nice enough to show you what your current client IP address is, where are you accessing this from, and in fact it makes it really easy for you to just add a new firewall rule for that IP address. At your work though, you're likely behind a proxy server. You could come in with a completely different IP address next time. Right, so you might want to go set up a range, that says, my work range or something like that, and it starts at some number and ends at some number. I'm going to go make it one. I'll just call it everyone, and it's going to start at 0.0.0.0 and go to 255, 255, 255. So this is going to let everybody in the world in. Don't do this, right? This is a demo, so I'm opening it up like this, right? But I got to press. Oh, enter doesn't do it. I love that enter wipes it out. Everyone. There we go. Click off it and then save. All right. So that should open or put those firewall rules in for me. And now, back over here, I ought to be able to just reconnect up. There it is. Cool. Now, when I get in here, if you're a SQL person, this may look a little more simple than a normal SQL server's Object Explorer would. In fact, if I go into my system databases, notice there's just a master, and that's it. But here's my BS demo database, and otherwise it looks like a regular database. You know? There's this federations thing. That's something you get in Azure that you don't get on premise, where we can actually help you shard your data out across multiple SQL Server nodes. So that's really cool. But otherwise, you can come in and create tables and things like that just like you normally would. You may notice, though, that when I made the database, it didn't ask me anything about data files and log files, MDFs and NDFs and LDFs. You have no control over the physical structure of this database. There's no file groups. There's no partition schemes. You don't know the physical storage, right? So if your database requires such control that you manage that physical performance, it may not be a good candidate to put in Azure SQL, right? Just because Azure SQL is there doesn't mean it's right for everything, right? But it's great when you don't want to have to maintain the instance. You don't want to have to maintain the physical storage. And in fact, just because it's in Azure doesn't mean it doesn't perform well. Again, with federations and sharding, you can actually take an extremely large data set, shard it out across multiple SQL Server nodes, and maybe get performance you dreamed of on premise, right? So it kind of depends on what your workload is as to how things fit in there. But so there it is. It's just a good old database, and it's ready to go. Let's go ahead and jump in here. We'll create a table. I do that all the time. Now it's just a table. Go for it. You know, it's normal DDL stuff. Again, things that require physical storage, I don't get. There's a few ICLR objects. There's some other limitations on here. One of the other things I can't do is notice that currently I'm in Bret's demo DB. I can't use another database. The use statement is not supported, and that's because, again, there's really no server through which you can switch to other databases. Right? For all you know, the other database is off completely on some other physical box. And there's no way for me to transfer my connection context over to that other database. Right? So you have single database connections, and that means you get two-part names, schema.object, not server.database.schema.object. So it's a little bit simpler, but again, as long as you can fit within the constraints of Azure SQL, it really cuts down a lot of the requirements that you have for managing the platform itself. So that's great. Another awesome set of services that we include with Azure is mobile services. And this is a new set of features that really has been very rapidly advancing over the past year. But if you're looking at building a client application, say for Windows 8 or Windows Phone or something like that, mobile services makes it very easy for you to get a service backend without having to know how to create a service layer. Right? You say, look, I'm a phone guy, or I'm an iOS developer, or I'm an Android dev, or maybe even better, a Windows 8 or a Windows Phone dev. Right? And you say, well, I want to write the app. I know what my app needs to do, but I don't want to have to figure out how to write databases and services and all that kind of stuff. I want to focus on the app side. That's where Azure Mobile Services comes in. So I'm going to jump over here. Actually, a sort of handy little slide here. Let me pop this up. The three big things that you get out of mobile services are a place to keep your data. So a mobile service includes an Azure SQL database on the back end. It gives you a way to authenticate your users using either Microsoft Live IDs or Microsoft accounts, Facebook, Twitter, or Google accounts, as well as push notification support, right? So all these phone devices, as well as like a Surface. So the Windows push notification services, iOS has their own push notification services, Google has one. They allow a server or some service up in the cloud to send data to the device and get pop-up notifications or that kind of stuff, right? And so push notifications are supported here in mobile services as well. What you get then basically is also a cross-platform set of APIs that you can use to call into this stuff. So Azure Mobile Services is, again, all exposed through a RESTful API. But to keep you from having to write all the low-level HTTP code, we give you API or SDKs for Windows 8, Windows Phone, iOS, and Android that you can use to build those apps with. So that's pretty cool. So you go out and create an Azure Mobile Service. On the back end, that comes with the SQL database. So part of the creation process will be to create a SQL database. And then there's going to be a set of data services that are actually implemented in Node.js, although you don't really see that. You also get the authentication services using those providers I talked about, as well as a RESTful API that gives you a way to sort of interact with those services out there. As I mentioned, support for push notification services, as well as a few other things. You can actually schedule server-side scripts to run, and you're going to write those as Node.js JavaScripts that you can either have run on demand, or you can set them up to run automatically. You get monitoring and logging, as well as integration with third-party services like SendGrid or that kind of stuff out there as well. And then from the client app, again, really the client could be anything. And you could just directly consume the RESTful API. But to make your life easier, we give you SDKs for all of the major mobile OS platforms out there. So let me jump over here and show you one of those guys. So under Mobile Services, I'm going to come in and click New. And Mobile Service and Create. And that's about it. I'm going to give it a name. Call it WAMS BS for Windows Azure Mobile Services. Oh, I've apparently all about BS WAMS. All right, that works. Again, I can either use an existing database or create a new one. If you use an existing one, all the objects that get created are going to be under a schema name that's your service name. So they won't conflict with other objects in the database. They'll all be sort of schema isolated in there. But I'm going to go ahead and let it make a new one here for me. Stick it in the West US. And since it's going to make a new database for me, I'm going to give the database a name and pick a server. I'll just use the server we just built. You've seen me build one, so we don't need to do that again. Put my credentials in. And the advanced settings are nothing more than the size and collation that we saw before when we were creating a database, and that's it. So I say OK. And it'll chug away behind the scenes there. So when you go back and look at Windows 8 applications, if I go to my Start menu here, and for example, say go run music or whatever, you'll notice that the app takes over the entire display. Right? So these look a little bit different than your traditional desktop apps would. We call these Windows Store apps. And they're apps that you would download and install from the Windows Store, right? So I could go back here, I could find the store, and then I could come in and find apps that I want to install and install them onto my device, right? And so let's say I wanted to write an app like that I could publish into the store and have other people be able to come back and download. So that's kind of what we're talking about here. I've got the back-end service for me, but maybe I want to have an app to help me track my to-do items or something like that, right? So I want to have a nice Windows 8 app to help me do that. When I navigate into my Azure Mobile Service on the Quick Start page, and that's the page with the little cloud and the lightning bolt on it, they actually give me sort of a little Quick Start app that I can use, and hey, it's just coincidentally a to-do item app. So I'll use their sample here. They give you links here to download the SDK if you don't already have it. But you'll notice up here that if I go to data, remember it made that BS WAMS DB for me? It says you don't have any tables in there. I haven't made any tables in the database yet, so that makes sense. Back over here, though, for the quick start, it needs a to-do table. So this button here would just go create the to-do item table for me. So you can click on that. I'll go ahead and do it. But what it's doing behind the scenes, I can show you, is no different than if I were to have just gone to data and then said create and typed in to-do item. That's all it did. And notice the default permissions is that only applications that have the application key are going to be able to get to this table here on the back end. And back over on the dashboard then, if I go to manage keys, there's the application key that somebody would need to be able to connect, right? So they need to know the service URL, the endpoint to where the service is, and that key, and then they can hit the RESTful API to interact with this. And that table has been restricted to only people that know the key. All right, back over to the table though, notice that if I navigate into it, it says that there's no records, but if I go to the columns page, I can actually see the columns that are in the table, and it came with an ID column. Every Windows Azure Mobile Services table has to have an ID column that's your primary key, right? So that's, if you go in and create them on your own, you can do that. You still have to have your primary key be ID, automatically incrementing value out there. All right. But that's all it did is make that. And if I were to go back to my SQL Management Studio and refresh, you'll notice it's just a database and it's just a table. You know, nothing magical. Notice though that it did schema qualify the table with my Azure Mobile Service name. So, but otherwise it's just a SQL table on the back end. Pretty cool. All right, so I let it make the table for me. And then the other piece is to download a sample app. So I'll go download that really quick. And I can download it either as a C# or as a JavaScript app. I'm going to do C#. In Windows 8 store apps, you can actually build Windows 8 apps with HTML5.js. It's really cool. But I'll go put this into my demos folder here. A little side note, whenever you download projects off the internet, regardless of where they came from, you want to unblock them before you extract them. And that'll keep Visual Studio from saying, are you sure you trust this source? I'll go and extract it all. All right, and notice it gave me a Visual Studio solution. So I'll just open that up. And in the project over here, I have a main page.xaml. If you've played around with WPF or Windows Phone, Silverlight, anything like that, this should look pretty familiar. But if I open up the GUI for that, give it a second to load. Actually, I might need to do a build here. There we go. And basically, you'll notice I have a text box here that I can type whatever it is I need to do into and hit save. And when that happens, I want to take this to-do item thing and save it up into my to-do item table up in Azure. And then I have a list box over here, or list view, that I want to use to show my current to-do items and basically anything that hasn't been completed. Right? If it has yet to be done, show it to me over here, and also give me a way to requery that data if I want to. So a pretty simple UI here. And when I click on the Save button, what this Save button is going to do is run this click event handler for me. And that guy's going to go new up a to-do item. Well, what's a to-do item? A to-do item's just an object or a class. Remember the ID column I said we had to have? So I have a column called ID. It's just a public, and then I have a property called text, which is going to be the text of the to-do. What is it you need to do? And a Boolean as to whether or not it's complete. Now these attributes that are up here above this show you that your object in the client could have a different name than the actual column back in the database. And this gives you a way to map up the different names. And that's kind of cool. Sometimes DBAs like to name things really ugly, and we can put nicer names on them if we want to. I don't actually have to have that in there unless I'm going to play around with the names. But I'm going to leave that all as is. That looks good. So that's my simple to-do item. Now remember on the data side, I only had an ID column. I didn't have a text column, and I didn't have a complete column. Back over in Azure Mobile Services, though, if I look at this, on the Configure tab, there's this option called Enable Dynamic Schema. And that means that the server can automatically generate new columns whenever you throw an object at the table. If it has properties that don't match up to existing columns, it'll just make new columns for you. So that's kind of cool as a dev. You know, it's kind of this code first pattern. If you're a DBA, you're like, no. So if you're no, we'll turn it off and just go make your tables ahead of time. You're good, right? But if you like the woohoo, that's cool, leave it on and just throw objects at your server. If I want new columns, should I make them in the database first or in the code first? That's the question. It's whatever you prefer. If you're a developer, you probably like code first, right? I don't have to go mess with the database. I don't even like SQL, right? On the flip side, if you're the DBA, you're like, I'm going to make it first, dang it. So you can make that choice. What this does is it enforces, if you set that to off, you have to go make it in the database first. If you have it on, you could make it in the database first, and if the column's already there, it uses it. But if the column's not there, it'll make it on the fly. The problem with dynamic schema on is that the user could accidentally or the developer could like accidentally misname a column or a property and not realize it until they've run it once and go, oops, well, now that bad column name exists in the table. And the only way to fix that is to connect in through a regular SQL tool and drop the column. Right? It automatically makes them. It doesn't clean up after itself, though. So it's not going to remove columns or anything, right? So, but it's on by default, and I'm going to leave it that way. So, so we new up one of those to-do items, and we set the text on it to whatever you typed in to the text input box, right? And then we call this method to go insert a to-do item. Well, over here in my app, I've created an object that's from the Azure Mobile Services Client API. So remember I mentioned there's these SDKs that make it really easy to work with this stuff. And in my app class, I just have this thing called a mobile service client that knows where my mobile service is and what the management key is. Because I downloaded this from the Quick Start, it has all the right values in it. It's all set up and ready to go. And so now basically anywhere in my app, I can just go to this mobile service and do things with it, right? So back over here, that's exactly what we do. I have a mobile service table of to-do items that is just going to the app's mobile service and getting a pointer to the to-do item table. It's that easy. This basically now, this guy right here, to-do table, is going to be where I go to insert, update, delete, query, whatever. It's so awesome, right? And then, so this is going to be how I work with the server-side data. Come on, mouse. There you go. And then I have an in-memory collection of to-do items that I can use for binding up to my list view and showing them and all that good stuff, right? So how do I work with the data on the server, and how do I cache the data down here locally to view it? So the insert to-do item just takes in the to-do item and simply says, hey, to-do table, go insert asynchronously for me the to-do item that just came in, and we just wait for that async operation to complete, and then we update our local cache with the new to-do item as well. And that local collection is bound up to my list view over here, and it's just going to go show those guys. Refreshing them, this is how we query it. We get that to-do table, and we just start using link queries on them. Where the to-do item's complete property is false, return that as a view, and then set the list items list view back there up to that collection that we just pulled back. Updating them, simply telling the table to go update the item. And in our case, the only reason you'd update an item is to mark its complete checkbox as false, right? And so the only reason, is true. The only reason we update is to mark them as complete. And once we're done with them, we don't need to see them in the client-side cache anymore, so we remove them from the local cache. And that's pretty much it. I mean, that's all my code. The last thing I'll show you is in the list box, we show you a checkbox for each to-do item, and you can turn that on or off to mark it as complete. We bind that up to the complete property. So let me just go ahead and run it really quick. And there it is. Right, so it's already round-tripped up to the server. It's already put that row in, come back, gotten the updated item, and showed it in the local collection. So if I go back over here to my data tab now and go into to-do item, there's the text and complete columns showed up. There's my data showing up, etc. Right, and remember I mentioned that if you added a new property, whether you meant to or not, you're going to get a new column in the table. So let's come back up here. Cool. So no, created. There we go. So So my created app property in there. And then when I go new one of these guys up, something like that. Cool. So I'll run it again. And so it worked. I don't see it because I wasn't asking to show the date time over here on the client side. But if I return back over to the browser and requery the data here, notice there's now a new created app column. It was that easy. I just kind of went into the client side and added it in. The ones before didn't have it, but the new ones do. And lastly, I can go back to my app, and let's mark this guy as complete. Notice he disappears, and back over here, we should see it's false. Change to true. Pretty cool. So that's great. It's that easy. I mean, you actually saw all the code. Granted, I didn't write it, but there wasn't a lot of code there. And there's a tutorial. If you jump back up to Azure's website, under documentation for mobile, right there, they actually walk you through tutorials for dealing with data, adding in authentication for users, doing push notifications, and even tying into third-party services or something like that. So it's very cool. All right. Oh, so going back there, if you look at the Azure Mobile Service, and the whole question of authentication came up, right? Should I roll my own authentication, or should I leverage an existing auth provider? And sort of the trend in the industry these days, at least for client apps, is to leverage an industry standard authentication provider like, Microsoft Live IDs, aka Microsoft accounts, Google accounts, Facebook, Twitter, whatever out there. And that's because users start getting all these different usernames and passwords across the board. There's nothing wrong if you still want to go build your own authentication scheme, you can. And just like you saw, I had a table in my Azure Mobile Service called To-Do Item. I could have had one called Users. And one of the properties could have been username, and the other one could have been password, and I could have encrypted the password however I wanted to, and figured out, how I wanted to authenticate my user. But the nice thing about these industry standard APIs like OAuth and OpenID is that as the app developer, I no longer have to worry about whether or not somebody's going to hack my database and steal my users' names and passwords. I don't have to deal with helping the user change their passwords. I'm just done. All I have to do is say, hey, look, if you have a Facebook account, you must trust Facebook. I'll go ahead and trust Facebook as well to properly represent you to me, right? I'm going to assume if Facebook gets hacked, I'll hear about it, right? So I'll use somebody big enough that I'm going to know if there's a problem. And we'll just agree to both trust Facebook. And so when you come to me, rather than you having to give me your own credentials, I'll just say, look, why don't you go prove who you are to Facebook? And I'll let Facebook come back to me and say, yes, this person is who they say they are, and here's some basic things about them they're willing to share with you, like maybe their name or their email address or maybe their photo or whatever else they deem they want to share with you. And I can also say, hey, Facebook, by the way, here's the things I'd like from that user. And when Facebook authenticates, they'll say, oh, by the way, this app wants all this data. Do you allow that? Yes or no? Right? And the user can choose that. And then I get back just a nice little authentication token, as well as ability to grab any of the data that I've been authorized to grab, right? And now I know who you are, and I didn't have to authenticate you. So there's this whole sort of thing around that. Now, you could go write your own client APIs to work with each of those providers specifically, but Azure provides a service called Access Control Services, or ACS, that'll help you leverage OAuth and OpenID protocols, but also other just standards authentication-based protocols, SAML and other stuff like that. And basically proxy out and build your own authentication layer if you want to. Now, this is separate than Azure Mobile Services. Azure Mobile Services kind of leverages this very opaquely, I should say, behind the scenes. You don't get to configure it much. But if you want to have your own full auth proxy, maybe even that ties in Active Directory authentication. You want to allow users to come to a web property that you host publicly, but in order to get to it, they have to authenticate with a Windows Active Directory account from your domain. And so ACS would help you set those types of federated authentication up. So that's pretty cool. I could have, you know, a user coming in, maybe using a web application or something like that, and we say, hey, look, we want them to access my website running off in Azure, but I'm going to have them hit Windows Azure's access control services, and access control is going to say, hey, what provider is it that they want to authenticate with? So my website might even ask them, do you want Facebook, do you want Yahoo, do you want Google, or whatever? And it's basically then going to pass me off to this ACS proxy, where I'm then redirected to Facebook, Google, Yahoo, or whatever, and I authenticate with them. They're the ones who ask for my password, right? Not my site. Facebook does, or Google does, or whoever. They're going to then create, as long as I authenticate correctly here, a token that represents me. And the cool thing about ACS is that it can take that token and normalize it so that I have a constant format of the data, regardless whether or not they authenticated from Facebook or Yahoo or whatever. So ACS can sort of normalize that for me and give me a standard authentication token back, regardless of the provider. And then it passes that back to my app, who can then forward that off to the website behind the scenes, right? And so ACS can sort of deal with proxying all that stuff out for me. That's pretty cool. All right. Another one I mentioned, and I've been honest here, I can spell Service Bus, and that's about my extent of knowledge on this. But Service Bus is a great set of services for wiring up your applications, right? Especially, again, going back to that term I had, loosely coupled, where maybe I want to have a client application that's on the far side of a firewall from the back-end service. Or I don't even want them to directly communicate. Maybe I want them to use queues or something like that. So I talked about queues from table storage, but Service Bus provides a more robust queuing mechanism that's in here. So we have a way to connect clients that are outside or beyond firewall boundaries with services on the back end. We have messaging for queuing and that kind of stuff, as well as service management and integration stuff on the back end. So it gives me a great way that I can take a service that's maybe hosted inside my firewall boundary and allow a client that's outside to actually connect. And the way that we do it is by proxying through the Service Bus to get there. So in fact, and then the other one we have is queues. And with queues, we have something similar to what we looked at with storage services, where I could put a message into a queue, and then I could have multiple readers, but each message is only going to get read once, right? So that's the first in, first out type queue that's there. We also have, however, what are called topics, and this is more of a broadcast type thing, where I can say, look, I'm going to send out a message about this, and then I could have various subscribers to that topic that all receive a copy of that same message, right? That's something I don't get with storage queues that are possible with Service Bus queues. So that's pretty cool. And like I said, it does give me a way to build apps, for example, maybe a client app that's running, consuming a service from the cloud or something like that, but that's actually hitting maybe some code running behind the scenes in my firewall. All right, so a lot of cool application building blocks. We've hit on some of the big ones there. We're not going to talk through every single one of them, obviously, but all of this is fully documented, windowsazure.com, and you can find out all about this stuff. All right, so Windows Azure, where do we use it at? Lots of different places where you have apps that need scalability, availability. We talked about redundancy and a lot of the different options that we have for that, and fault tolerance. So we see it used a lot in websites, compute-intensive apps where I need that on-off type workload that we talked about at the beginning. Backends for device applications. Windows Azure Mobile Services is a great example of that. When you have an API that you're trying to host, in fact, a lot of the folks that are heavy users of Azure are exposing an API that's being consumed by other applications elsewhere. Social gaming, other things like that are good scenarios where Azure is a good fit on the back end. We talked about the sizes of the virtual machines, and actually, I think that's still current. You'll actually find that these vary across some of the different offerings out there, but this would be if I'm looking at web roles or worker roles, 2 cents an hour for an extra small instance, all the way up to 96 an hour for an extra large instance there. But with that, I'm getting more processing power, more memory, more local storage, and more bandwidth allocated as I move up the stack there. So you can kind of pick the one that you want. The cool thing about that is you could start small and then say, hey, look, let's try it as it is, and then bump it up to a larger one later on if you want to, or scale it back down. Or the other one would say, let's always use the smallest size VM that we can. We'll just spin up multiple copies of them as we need to and farm them out that way. Right? So you have a lot of control over sort of how many instances you have, how much resources they consume, and therefore how much you're paying for those. So getting started, remember I mentioned there's a free trial if you don't have it. If you're an MSDN account holder, MSDN comes with Azure benefits. If you're a startup and you don't have MSDN, there's a great program from Microsoft called BizSpark. And you can go to Microsoft.com, whack BizSpark. It's for companies that are 3 years or younger and make less than $1 million. And you can sign up for BizSpark and basically get free access to MSDN, get your free software, Visual Studio, Windows 8, Office, server platforms, access to the stores, lots of cool stuff in there.